So let's open the workbench, the 2023 release 2. We have already prepared geometry in SolidWorks. So we'll just import the geometry and we'll do the further analysis. So first for fluid flow fluent option, in that you have to look for the geometry import. So this is how the file, need to click on design modeler. You can use space claim or you can use discovery also, but depends where you are comfortable in. So I have opened the geometry. Let's make it generate. So this is how the part has been there. So we are trying to do the analysis on the fluid part. It's the fluid which is moving inside. So that's why I changed this to a fluid. So this will be the opening through which the fluid will go in. So that I am going to specify. So let's make it generate one more time. Now let's close this file, go back to the workbench window, go to the mesh option. In mesh you have to generate the mesh, but preferably we'll try to generate the mesh which is somewhat default, so that we'll just check out whether the results are going in the right way or not, and if things looks to be on the right way, we'll go back and change the size of the mesh, or you can further modify the mesh also as per the requirement. So first of all I will generate the mesh as a default mesh. You need to give the naming to each and every uh, okay, so this is just a default mesh generated. So let's give the name selection. This one I will say inlet. This one, these are the three which I have specified. Inlet, this one, two, this is third, let's specify the last one. Okay, so we'll specify this as inlet. Okay, like the fluid is flowing, so we'll specify this is inlet. Now similarly on the other side we'll specify outlet. So first select all of the faces which are required to be specified as an inlet. This one, this one, so we can modify the mesh later on just to check how the things are going. I'm going to do this. Let's make it outlet. Okay, so this is inlet outlet, and we want to apply the thermal boundary condition at the inside of the wall. So preferably the inside things will specify with the help of wall. So all of them are specified to avoid the issues later on. So all of them has been specified with, we are just selecting all of them so that we can define the phase of define the object over there, because it has to be specified as a boundary condition. So need to check this one, and this is the last one. So all of them I will specify as a cell wall. So create name selection, I will write this as a cell wall. So lithium ion cell which is there, so make it update. You will see the mesh translation to fluent is successful. So you can check out the statistics. Right now it is 41,068, that is number of nodes, and 1,81,576 are element. So I'm keeping this as it is just to check how the things will proceed. And then okay, so we are done with the mesh. You can proceed further. So go to the setup, edit. So there are total, I will select 4 number of processor double precision. Let's take it start. So we are going to define material. We are going to define the liquid which has been used. So we are trying to go with water as a working fluid. So using water as a working fluid as a convenient fluid just for our analysis. Then first of all transient, then it is gravity. Let's put it 9.81 in negative direction. Then model, you can see energy equation is turned on, make it okay. Then K epsilon enhance wall treatment, thermal effect and curvature correction is made on. Remaining things kept as it is. Then cell zone condition is there. Sorry, the material is there. We need to select the material. I'll select water as a working fluid, that is water liquid. Copy, close this window. You can see water liquid available here. Cell zone condition, I'm not going to change anything, I'm keeping as it is. Then boundary conditions, inlet, so this is how inlet, then it is outlet. So you can specify some conditions, just check. I may specify some velocity. Say for example I specified it is 1 meter per second, make it apply and then close it. No thermal boundary conditions are applied at the inlet. So the cell wall which we are having, so we are going to apply some boundary condition there in terms of thermal. So let's go to the thermal. I will apply temperature, say for example 323, make it apply and then close it. So these are how the boundary conditions which I consider. I consider only one fluid, that is water, which is flowing through it. Then you go to the initialization, you say compute it from inlet, make it initialize. uh, no need to actually go on to patch the things because the phase change is not been available. So calculation activities, you can make it save 20. Animation, so what you want to visualize, that you can specify, say contours. Now I will need temperature, I will specify the wall temperature. Okay, where we want to visualize at each and every portion. Color map option, I can take it to float, so make it apply and close. So this is regarding to the first animation, make it save display, close this, and you can save the name also here as wall temperature. Okay, just a minute. So this is has to be selected, make it wall temperature, make it okay. Now if you want additionally, you can specify the velocity parameter, velocity magnitude, inlet outlet wall. This is one thing, make it save display, and you can make it as velocity contour, save display, then close it. This one velocity you may specify as a velocity contour. Okay, just a minute. So you may specify this one, sorry, This was, I guess, temperature. Okay, not there. Okay, so the contour 1 is wall temperature. This one is velocity. So let's check it whether this is animation 1. It is related to your velocity. In addition, you may have one more, say density. New object, contours, contours of density, where we want to visualize at all. Make it save display. Close this. Then contour 2, you may specify this as for your density. In addition to that, you may go and edit this. Okay, color map option you can select as float, make it apply, then close. Then save display, you can close this also you can close it. Now let's go back to the graphics. You will see the path line. I will specify some particle variable as is velocity, say magnitude of velocity. Make it save display. Let's check it, the pulse. Let it to complete. Okay, so we can visualize some velocity magnitude. So let's take it the pulse. So it can take some time to visualize the things in terms of velocity. So you can see how the fluid is moving. We have taken some higher value of velocity, so that's why. So this is a wall temperature. You can see comparatively higher temperature here. So the in between spots become red. So that will is the result of higher temperature with respect to the with reference to the cell. And you can see this also becomes yellow. So temperature increase occurs. At the same time, the temperature increase is occurring here also. So what are the other parameters? Let's check it out. Okay. So you can see it becomes somewhat hot. If the flow rates are comparatively higher, there are chances that this will get cool because of the flow of fluid. If the flow rates may be somewhat mm, the fluid which is flowing, it's taking away the heat. So you can see some portion which is in between. This becomes somewhat yellow. So you can see somewhat drop in the temperature when the fluid has been flowing in between them. So this is how the fluid is interacting and taking heat from the wall surface of the cells. So the most of the portion here it becomes earlier it was red, now it has become somewhat yellow, means some drop in the value of temperature near to the. So this region also you can see somewhat yellow. So over the time you can see this might become yellow. So that is actually the taking away the heat from the wall of the cell. Okay, so most of the portion here is somewhat yellow, so the temperatures are comparatively less as compared to how it is at the wall. So same way this you can see throughout it, the temperatures are less on this side. Let's check whether this will also become somewhat yellow. So last two time steps are remaining. So not much of the variation in temperature as far as the first row is been concerned. Okay, let's show you the animation. Okay, so let's see this one first. Make it 10. Just check. Make it like say 1 and let's play.